We're going to be simplifying expressions involving radicals. Alright, for our first problem here, we're just going to do a little bit of review here. So if you remember, you can separate each one of these terms. So square root of 81, square root of x to the fourth, square root of y to the sixth, and the square root of 81 is 9. And also you remember that since it's square root, there's little 2's there. They just don't put them when they're square root because it's assumed that it's there. So we're looking to see how many times will 2 go into 4, because what times itself would give me x to the fourth? Well, x squared times x squared is x to the fourth. So 2 will go into 4 2 times, so I have x squared. So that's how many times. It's divided up there, and when you divide it, then that's what it's going to be. So same thing here. What times itself 2 times, because that's what the little 2, the index there, is asking, and that would be y to the third. So our answer would be y to the third. So you can just think of it as how many times will 2 go into 6? Goes in there 3 times, so it's y to the third. How many times will 2 go into 4? 2 times, so it's x to the second. Next one, let's try square root of 25 n to the third. Alright, so let's separate each one of them. And so we have the square root of 25 is 5, and the square root of n to the third, and again, there's a 2 there. So 2 will not go into 3 evenly, but how many times will 2 go into 3? Well, it'll go in there 1 time, so we'd have n to the first. And how many do we have left over then? We have 1 left over then. So our answer then is just going to be 5n square root of n. So that's our answer there. And next one, we have 36 x to the fourth, y to the fifth, z to the seventh. Alright, let's separate them again. 36 square root of x to the fourth, square root of y to the fifth, and square root of z to the seventh. Okay, the square root of 36 is 6. These are perfect squares. So a perfect square, just a reminder of that too, is like 36. Square root of 36 is 6. That's a perfect square, 36 is. Square root of 25 is a perfect square because it's 5. Square root of 81 is a perfect square because it's 9. Square root of 4 is a perfect square because it's 2. Square root of, let's see, 100, because that is 10. So those are called perfect squares. So anyway, so we have our 2's there. Like I said, you can put them there. You don't have to have them there. So square root of x to the fourth. So how many times will 2 go into 4? Because what times itself would give me x to the fourth? Well, that is x squared. Next one, how many times will 2 go into 5? Well, it doesn't go in there evenly, but it'll go in there 2 times, and then I have 1 left over. How many times will 2 go into 7? It'll go in there 3 times, and then I have 1 left over. So just to clean it up a little bit then, I have a 6 and an x squared and a y squared, done with those. And let's see here, z to the third, and then I have a square root of y, square root of z, and you can put those back under together so they're together. You don't have to have them separate there. So that's just a little review of finding the square root, cubed root, anything. So you're finding out that index, in this case it was always squared, square root, seeing how many times that index would go into the exponent. Now on this one, what if we had 2 of them? We're multiplying those 2. Square root of 5 n to the 6th z to the 7th times square root of 16 n to the 7th z to the 9th. So you can separate all those. Square root of 5, square root of n to the 6th, square root of z to the 7th, times square root of 16. You can put the times there. You don't need to because everything is multiplied together. square root of n to the 7th, square root of z to the 9th. Alright, square root of 5, I can't take the square root of 5. You're not seeing how many times 2. Remember the index is 2 there because it's square root. You're not seeing how many times 2 goes into 5. You only do that with exponents. So how many times would 2 go into 6? It go in there 3 times. Goes in there evenly, so it's n to the 3rd. How many times will 2 go into 7? It'll go in there 3 times. And then I have 1 left over. Square root of 16 is 4. Square root of n to the 7th, excuse me, it goes in there 3 times, and then I have 1 left over. And square root of z to the 9th, that'll go in there 4 times. So it's going to be z to the 4th, and then I also have 1 left over. Alright, to clean it up a little bit then. So let's see, let's put our numbers first. So we have a 4, then the square root of 5. So I'm done with those. And let's look at the n's there. I got an n, the ones that are not underneath the radical sign, just the ones outside of it. N to the 3rd times n to the 3rd, because that's multiplication all the way through there. So that's n to the 6th, so I'm done with those. And so I have a couple of z's that are not underneath radicals, so I can put those together. So that'd be z to the 7th. And let's see then, done with those. And then I have a square root of, let's see, a z and a z and an n, so we'll do the square root of z times square root of z equals just z. So that's another z there. Done with those. And then I have all I have left is a square root of n. So I cleaned it up a little bit there. I still got 2 z's that are outside, so I can still put those together. So you really got to look at these carefully and put everything that looks alike together. So I have my 4 square root of 5. You cannot put those together because 5 is underneath the radical, so it has to stay there. 4 has to stay outside. Then I have an n to the 6th. The z's are outside of a radical sign, so I can put those together. Z to the 7th, and there's a 1 there. So that'd be z to the 8th. And then I have square root of an n there. And clean it up one more time. I like to show all the steps so you can see exactly what I'm doing on here instead of jumping some steps and not understanding what I'm doing. So I have 4 n to the 6th, z to the 8th, and I can put the 2 terms that are underneath radicals back under together, 5n. So then there would be my final answer. So it takes a little bit of time to get everything together, but if you take your time on it and look at each one of them separately, and then put the like things together, the ones that are underneath the radicals and the ones that are not underneath radicals, and the numbers that will go together there. So usually they always put the numbers first, then the ones that are not underneath radicals, and then the radicals, the terms that are underneath the radical last. So it's not really wrong the other way if you have them in any order, but usually you'll see in books that's exactly how they are. With the numbers first, ones not under the radical, and then the radicals. The next concept we're going to look at is adding radicals. Now we cannot add these together because they don't have like radicals on there together. So we have to get some that are like together. So let's say we have something like, let's review something here. Let's say I have 2x plus 3x. Well, from what you know about that from algebra, that's going to be 5x. So if I had 2 square root of 3, just as an example, and 3 square root of 3, my answer is going to be 5 square root of 3. So your radicals, as long as they look exactly like square root of 3, square root of 3, those act just like a variable, just like the x's did up here. You don't do anything with those on there. So you don't add them together really, you just, what do they have in common? So as long as they're the same, then all you're doing is adding these numbers out front, the coefficients, And that's how I got the 5. So that's what 2 plus 3 is 5. And then you just bring along the square root of 3, the term that they have in common there. So we want to try to see if we can get these terms in same radicals here. So I have 5. Now I'm trying to look for what is the perfect square of 50. So I'm looking for a number that has a perfect square that will go into 50. So I want the biggest one that will go into 50, and it's a perfect square. Remember from the previous pages, square root of 4 is 2, square root of 16 is 4, square root of 9 is 3, square root of 100 is 10. Those are all perfect squares. So the largest perfect square that go into 50 is square root of 25 and square root of 2, because 25 times 2 is 50. Plus 8, what's the biggest perfect square that will go into 32? So take some time to think about that. But the largest number, perfect square that will go into 32 is 16. So square root of 16, square root of 2. And my last one, the largest number, perfect square that will go into 8 is 4. And then square root of 2, because 4 times 2 is 8. Alright, so now to clean up a little bit, that's 5. Square root of 25, that's also 5. Then I have square root of 2, I can't take that because that comes out to be a decimal, it's not a perfect square. Then I have 8. Square root of 16 is 4. And then I have square root of 2. Minus square root of 4 is 2. Then I have the square root of 2. Alright, a little bit more cleaning up. 5 times 5 is 25. Square root of 2. Plus 8 times 4 is 32. Square root of 2. Minus 2 square root of 2. Alright, and the last part of cleaning up, since they all have the exact same radical there, square root of 2, remember that is just like if this up here, where I had 2x plus 3x is 5x. So all I'm going to do is look at these numbers in front and put those together, and then with the square root of 2 at the end, because that square root of 2 just acts like a variable, just like the x did. So 25 plus 32 is 57, minus 2, 57 minus 2 then is going to be 55. So then that is going to be our final answer. So once again, you might have to go back, rewind this to listen to carefully what I'm doing in every single step. And probably the hardest part would just be finding the largest perfect square that will go into the ones underneath the radical. Like the largest number that's a perfect square that goes into 50 is 25. And for 32 it was 16, and for 8 it was 4. Alright, you can see on this page just a couple review here. So if I take the square root of a number times the square root of the same number, it's just that number. I've already shown that on the previous pages, and that's a review from other lessons. And one other thing, we're going to just quick review, is we're going to multiply n plus 2, n minus 5. So we're going to double distribute that. So that would be n squared, that would be negative 5n, that would be 2n, and that would be negative 10. Alright, put my like terms together. Negative 5n plus 2n is negative 3n minus 10, so that would be my answer there. So that's just a review here. You're going to see in a minute why I did that. So let's say my problem was 5 plus 2 square root of 7 times 6 minus square root of 7. Alright, so I'm going to double distribute this. So that's going to be 30. That's going to be negative, because there's a negative sign right there, 5 square root of 7. That's going to be 12 square root of 7. And then my last part here is going to be minus, because once again I got that minus. So 2 square root of 7 minus that, or excuse me, the times that negative square root of 7 is going to be 2 square root of 7 times square root of 7. Alright, so now to clean up, once again I like to show every step I'm doing and how I'm getting those. So I have 30, and I can put these together because from the previous slides, as long as they have exact same radicals with the number underneath it, I can put those together. And you only look at the numbers in front, the coefficients. You don't do anything with the radicals when you're adding them in there. So if you need to go review in the past couple slides, I would go back there and do that. So we have negative 5 square root of 7 plus 12 square root of 7, which is going to be 5 square root of 7. And then my last part here, right here, negative 2 square root of 7 times square root of 7. This right here is 7 because of this concept. Square root of number times square root of number is just that number. So I have negative 2 times 7, which is then 30 plus 5 square root of 7 minus 14. And to do some more cleaning up here, I can put this together and this together. I cannot put it with the 5 square root of 7 because the 30 and the 14 do not have a square root of 7. So 30 minus 14 is 16. So I'm done with those. And then I have my plus 5 square root of 7. So that would be my answer. I cannot put those together. So be very careful at that. You cannot make that then, let's see, some people think it'd be 21 square root of 7. It cannot because the 16 does not have a square root of 7. So that is my final answer right there. So they have to have the exact same radical with the number underneath it, same number, before you can add the coefficients out front. Since they don't, that is my final answer and I can't go any further then. Alright, here's our last concept then. This once more is a review. So let's add n plus 2 times n minus 2. So if I double distribute that, I'd have n squared, 2n, negative 2n, minus 4. Put my like terms together. 2n minus 2n is 0, so I just have n squared minus 4 would be my final answer. So taking the, like the n plus 2 times n minus 2, those two are called conjugates. They're kind of like opposite each other, so it's called the conjugate. So let's say one more kind of review here, and then we'll do our example, and you'll see why I'm doing this here. Alright, so we're going to double distribute that. So that's 25, negative 5 square root of 3, plus 5 square root of 3, and square root of 3 times negative square root of 3 is negative 3 times square root of 3. So I'm going to write that out just to show you what I'm doing that extra step for you. So let's see, we have 25, and I can put these two together because they both have a square root of 3 underneath. So since they both have a square root of 3, you can add your coefficients, the 5 and the negative 5. Those cancel out. Just like they did up above, the n plus 2, n minus 2, the two middle terms canceled out. Then I have minus, and that right there, square root of 3 times square root of 3 is 3. So I have 25 minus 3, which would be 22 then. So that's square root of 3 times square root of 3. Last couple slides I've done that. Any number, square root of a number times square root of the same number is just that number. So our problem here is going to be then 6, the last concept, 6, 2 minus square root of 7. Alright, so we want to simplify that because you cannot have a square root in the denominator. That's why we need to get rid of that. That's the reason why we're simplifying it. So anytime there's a square root or any root in the denominator, you need to get rid of that. And in order to get rid of that, we're going to use this concept right here. So I'm going to take it times its conjugate, which is 2 plus square root of 7. So since this was a minus, I'm going to use a plus here. If this would have been a plus, then I would have used a minus there. So you're just using the opposite of it. Whatever you do to the bottom, then you have to also do to the top. Alright, so on the top then I would have 6 times 2 plus square root of 7. And on the bottom, if I would double distribute that, I'd have 2 times 2, which is 4, then 2 times square root of 7, which is 2 square root of 7. Then I would have this term right here, which is negative 2 square root of 7. And then on the back, last part, I would have negative square root of 7 times square root of 7, and just like I did from here, where I have negative square root of 3 times negative square root of 3, which is just 3, then that would just be negative 7. So if you need to go back, rewind this to listen to my example again, I would do that. So the negative square root of 7 times the square root of 7 is just 7, because the negative times the positive is negative. Alright, so to clean this up, those two cancel out because they have the same square root of 7, and one's positive, one's negative, positive 2, negative 2, so they totally cancel out. So now I have 4 minus 7, because that's what's left, which is negative 3. Alright, so that's what I have on the bottom. So if you need to, I know it might seem kind of confusing, stop it, rewind it, listen to it again to help yourself. So then my last part here is going to be 12, distribute that, plus 6 square root of 7 all over negative 3. And since 3 will go into 12 4 times, that'd be negative 4. All I'm doing is simplifying that. You learned that in when you learn fractions. 12 over negative 3 simplifies to negative 4. And this one does too. Negative 3 and the 6. Just looking at that, that simplifies down to negative 2. Then I have to take that square root of 7. So that's how I simplified that. Now if they did not go into it, let's say this was, we'll just pretend that this was the answer right now just to help you. So let's say it was 5. Well, 12 and 5, 12 over 5 does not simplify evenly, so I'd leave it alone. And it's either just 6 or 5. So that would be my answer. But like I said, that was just an example to show you if it doesn't go in there evenly. So don't worry about that one. But if you had something like that as a problem, then you would leave it alone. That would be your final answer. But since I can simplify this back to this one, I take the negative 3 to the first term, the negative 3 to that second term, the coefficient there, simplify those two, and then just bring along the radical as my final answer. Alright, and once again, take your time, go back over the video, stop it, rewind it, listen to what I'm saying in there, because I give an example step by step on there. Might be a little bit confusing, but I think if you take your time, rewind, go back, look at the steps I did, listen to it, I think you're going to be able to get those and apply them to your homework or a quiz or test.